So hacking passwords really all starts with footprinting. Hopefully by now you've got a fairly good idea of the user accounts on the system. You saw that in the enumeration, in the passive footprinting, active footprinting phases, how to actually enumerate users, figure out what user accounts are out there, and hopefully which ones have which privileges. Understanding the current password requirements. So whether the target environment uses 7-character passwords, 8-character passwords, whether they require complexity, how often they require change because that impacts how fast we have to move. All of that stuff is important to know at the outset. And as I mentioned a little while ago, knowing which accounts to hack first is useful. It's not critical, but it's absolutely useful because remember, any success is useful, but that doesn't mean everything has to be a success. And there's two different categories that I want to approach here, both technical and non-technical password hacking. Technical password hacking is the one I'll cover first. Non-technical, a little more interesting, a little more subtle. Within technical password hacking, there's a number of different approaches, actually. Some are really, really efficient and effective and common, hopefully common to you. Some of them are not. And so I'll cover all of these: network sniffing, online guessing, hash grabbing, hash injection, offline cracking, which is probably the one that most people think of when they think of technical password hacking, and keylogging and software spying. Network sniffing is an interesting aspect. Most administrators don't really think that if they've got an FTP account for a user and a domain account or a local login account, that the user is going to use the same password for both. But human nature almost defines the fact that users use the same password on as many systems as possible because it's the easiest to remember and the most efficient for them to type in. If they have to log into 5 separate systems every day, they're probably going to want to use the same password on all systems, especially if they have to type it in all 5 times. Luckily for an ethical hacker, some systems don't require or even support some type of encryption or hashing for the password. Many of them use plain text passwords. The easiest ones are certainly FTP, Telnet, basic SQL authentication, basic HTTP, not secure HTTP. All of these and more, many, many more, in fact, use plain text passwords and don't encrypt and don't protect the passwords. So if we can sniff the network and watch for this clear text traffic, not so much for the data that's going across within a transaction. We're not looking necessarily for an FTP file stream or VoIP stream. What we're looking for is the authentication or the password passing. If we can capture that, we could potentially use that password to figure out what their other passwords are, their local login password or the domain login password for the same user. It's probably either going to be the same or some minor variant. So as user 1 might use FTP pass123 for their FTP password, well, if they also have a SQL login, you could probably guess that it's going to be SQL pass123 or some variant of that. It's not going to be terribly dissimilar. This is a bit of a simple example, but if you can start sniffing basic passwords, you can probably use that information to footprint and make educated guesses around other passwords that are certainly going to leverage more resources or access more resources, get you further. As I mentioned, all successes are successes because they can all be built upon. This is one way we build upon a simple compromise. FTP might not have anything of interest, but we still want to sniff it so that we can use something there to gain access to something else of interest. Online guessing is really, really simple and straightforward. It's you sit down in front of a computer, you press Control-Alt-Delete probably, and you try to log on over and over and over again. Oftentimes the username and the domain name are populated. Actually, there's a setting in Windows that disables replacing that on the window, and so it has to be typed in every time. But typically speaking, the username and the logon to domain are already there. You just need to guess the password. And online guessing is just literally sitting down and doing as many as possible. This is exceptionally slow. It sets off all kinds of alarms. If the user has any kind of account that's subject to lockout, that's not a highly privileged account, it's going to get locked out pretty darn fast. and the user will definitely know that the account has been locked out because a window will pop up and say, hey, this account's been locked out. That could be a major problem. In older versions of Windows, you could just hit escape and actually log in with no context at all. Yeah, that doesn't work anymore. That's really not been the case for probably the last 10 or 12 years. But I still occasionally hear people say, well, I just bypassed the login. No, you probably didn't. Or if you did, you logged into a local account with no password on it, which is actually fine. If you get a local login, you can certainly use that to access other resources. But on a typical domain joined machine, that's probably not going to work. So remember, a little bit ago, we talked about the fact that passwords are stored as cryptographic hashes. The passwords are actually never stored in plain text. Administrators never have access to raw passwords, original passwords. They only maybe have access to the hashes, the cryptographic hashes of those passwords. And when a user logs in, typically the password is hashed, and that hash has to match the hash that's kept on the server or the authority that they're trying to log in against that actually authenticates and authorizes. That password hash there has to match the password hash that's created locally when the user types in the password. So really, there's two options for attacking that. You can either replace the server's copy of the hash with one that you already know. So you type in ABC123, you get the hash for that, and you somehow replace the server's copy of the user's hash with the hash of ABC123. If you can convince the server that that's the correct hash, you can now log in using your own password. This, of course, will almost certainly inform the user or the administrator because now their original password doesn't work anymore. And it will only probably be good for as long as the user doesn't try to log in. After that, you're going to get the password reset, so you've got to make your attack work within that time frame. Option 2, which is far more common, is getting a copy of the hash from the server or from somewhere and figuring out the password that matches it, actually going ahead and doing what's called password cracking to figure out what the hash equates to in plain text. What is the proper set of characters that I can type in that will hash to the same value? That's the password that I need to use to log in, and that will work. Most often, option number 2 is conducted by what we call offline cracking, which is where you go and grab all of the hashes that you can possibly find, preferably off something like a domain controller or a AAA server or Radius server or VPN server, something like that. You grab all of the password hashes that you can possibly find, and then you feed them into a tool whose only job in life is to try all possible hashes. There's different types of attacks in this offline cracking process. And first of all, I want to make sure you understand there's a difference between online and offline. Offline cracking is when you've got the hashes and you've got them on your computer or a cracking machine, and you're trying all possible passwords or different combinations without actually interacting with the target network. You've grabbed the password hashes, you've stored them on this machine, and now you've got this machine working hard. You're not actually doing any kind of online authentication attempts. You're not actively penetrating the network now. You've got the information. You've hopefully disconnected from the network, in fact, and you're offline attempting all of these passwords. One common attack certainly is the dictionary attack, which is where you have a tool feed in every possible word hopefully in the user's native language to try to find out if any of those words match either part of or all of their password. Why does that work? Well, think about it. Most users use words as part of their passwords, if not all of their password. So if my password is I love fish, no spaces, no upper, no lower, all together, well, those are all words, and a dictionary attack will contain all possibilities of those words together. There are also attacks known as brute force attacks, which are the more common conception when people think of attacking passwords, which is where this software or device throws all possible combinations of letters, numbers, punctuation, non-alphanumeric, all that kind of stuff at the hash. It simply calculates a hash based on some random input and then throws it against the captured hash to figure out, do these match? is there a match between this pseudo randomly generated hash that I've got and the stored hash? If there is a match, then that means that this is the password. That's really cool. They can go one at a time, but actually there's ways to accelerate this using GPU systems, using CUDA for NVIDIA systems and so forth. You can actually make this stuff work really, really fast, but ultimately it comes down to brute force attacks are limited a little bit by the fact that you've got to generate all these hashes and then throw them against the table. The nicer, more elegant approach that has some drawbacks but a lot of positives is that you have a system that's pre-computed every possible hash value for a system based on, let's say, you know that the network, based on your footprinting, requires alpha and numeric, but not any non-alphanumeric characters. What you can do is actually download a table that's called a rainbow table, which is pre-computed with every possible hash value based on the character set. So you'll download a rainbow table that's a table of all possible hash values of alphanumeric characters. Then the tool, all it has to do is look in that table to see, is there a match between any of the hashes that I've captured and any of the hashes in this table? If there is a match, I immediately have the password. This works really, really, really fast, but it requires a lot of pre-computation. You either need to go get these rainbow tables off the internet or off another tool, or you need to sit down and calculate them yourself using a tool and an awful lot of horsepower and storage. And that actually leads into the other drawback. These rainbow tables, because they are a list of every possible combination, can be exceptionally difficult. Right now, to download all possible values for LANman and NT-LANman hashes against a Windows server, to actually try to get a rainbow table attack against a Windows server, to download all of those hashes and store them on a hard drive is roughly about, I want to say, 7 terabytes. And that's actually in a compressed form, 7 terabytes compressed. It's much larger using an older uncompressed table type. So this can actually be a really cool, really efficient attack, but it does require you to do some work in advance, like get a giant drive array and actually download all of this data or generate all of this data. Downloading it takes an extremely long time. The only thing that takes longer than downloading all of that data to your array would be actually generating it yourself and storing it. That'll take far, far, far longer. These are generated generally by distributed computing projects. So that is, if you're going to conduct any type of attack against password hashes, offline cracking attack, the best way to do it typically is going to be to grab the hashes, store the hashes offline, and then run an attack against them, preferably using rainbow tables based on your knowledge of the footprint of the password, how the password is composed, what the passwords look like on the network. Use the appropriate rainbow tables to try to get a password. And that will almost always work. It just requires an awful lot of work in advance and a little bit of luck.